Okay guys, welcome to the online Shahid program. We will discuss about the digital basic technology subject. In that we will learn about the topic combinational logic circuit. The last week we have learned about the digital basic logic gates. In digital basic logic gates we have learned about the different logic gates and or, not, NAND gate, NOR gate and XOR and XNOR gate. The last week we have discussed about that one. So we have recall this one, all this thing, and then truth table also we have to remember all this one. Now today's topic we have to learn about the combinational. Combinational means the one or two logic gates can be combined and produce one output. In that case, we have to use different logic gates and produce the output. So, combinational logic circuits are the logic circuit which are the memoryless. They don't use or they don't store any memory. Memoryless digital logic circuit whose output at any step, any time will be only depends on the combination of the inputs. Or in other words, we can explain about the combinational logic circuit. The output is dependent at all times on the combination of its input. Thus, a combinational circuit is a memoryless. For example, a combinational circuit may be AND or NOT, any type of circuit, and that output will be depends totally upon inputs. For example, we have the output here and we are applying some input. So input may be 1 or 2 or 3. We can use that 2 or 3 gates. According to the input, whatever the input we are applying here, and the function of the gate, logic basic gate, the output will be produced that one. Okay? For example, we will know that one. What is this? This is AND gate. 2 input AND gate. So this is the AND gate, A and B, and this output of this AND gate is given to the OR gate and produce the Y. This type of application will be used in many applications here. So this is the combinational circuit. In this combinational circuit, we are using one AND gate and one OR gate. So we have to learn about what will be the output. It is not the output of the OR gate. It is a combination of the output of the AND gate as well as the one input as the C here. So if you see the truth table of this combinational circuit, we can learn here, we can see this one, A, B, C. These are the inputs. And we have the one output Y as a one output of the OR gate as well as the one output of the AND gate as X. So we have the two output X and Y. So we can say these are inputs and these are X and Y are output. So whatever the combination of A, B, C it will be produce the output X as well as the Y. So we will see one by one all the outputs. For example, A0, B0 and C0. What is A0, B0? Means A0, B0. We know that one. You have to remember the truth table of AND gate. What is the truth table of AND gate? A, B, say Q, 0 0 0 1 1 0 1 1 0 0 0 1, except the last, if the all inputs are 1, the output is 1, and for OR gate A, B, Q, 0 0 0 1 1 0 1 1. So here the output is all 1 except the first is 0. So recall yourself, this is the basic logic gates of AND and OR. If you remember AND and OR, truth table of AND and OR, you can do the example of this combinational circuit. Now we'll do one by one. Okay? We have to write first all combination 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0. Here 1 0 1 1 1 0 and the last one all ones. How can we find out the number of combinations here? By 2 power 3 inputs. So we have the 8 combinations. 1, 1, 2, 3, 4, 5, 6, 7, 8. These are the 8 combination. Here we can have the combination as 2 power 3. It is a binary number, only 2 numbers, 0 and 1. Power of 3 means 3 are the inputs, A, B, C. So if you keep number of inputs are 3, you have to put 3. If number of inputs are 4, you have to put 4 here. So the combination will be increased, 4, 16. Now in this case we have to see what will be the output. Okay. Now come to the point, the truth table of this combinational circuit. If all 0, what will be the X and what will be the Y? We will see one by one. 0 0 combinational. This 0 0 is AND gate for A and B. So the output of the X will be 0. Okay? When all AB, if both are 0, you can put here 0 because it's 0. And we know that one, if any one of the output is 0, except this, except 1 1 0, the all will be 0. You can remember, you can see here, X will be from A and B input. Only see A and B. If any one of the input is 0, you put the output as a 0. See here, 0, 1 0, so 0. Here also 0. Here also 0. Here also 0. But here in this 2 case, we have the output as a 1. We have the output as 1. Why? Because the value of the A and B are high. 1, 1, 1, 1. So output will be high according to this truth table and truth table. Okay? Now, what about the Y? Y is the output of the OR gate. But the Y is the output of the OR gate, have the 2 inputs X and C. So we have to see the output X, C, X. We have to see the combinations of C and X. As we know that one, in an OR gate, if any one of the input is high, the output is high. So you have to check with this C and X, only this part. C, CX, CX, this one, CX. Okay. 0, 0, 0. If any one is high, either high, high, 0, high, 0, high, high. And the last one is again high. If any one of input is high, the output will be high. Okay. So this is the logic truth table for this combinational circuit. Hope you will be understand this one. I will take one more example. One more example I will take. Remember logic gates. What is this? NOT gate. This NOT gate is given to what? NAND gate, and one input is from input side. Say this is A and this is B only. Okay? And we have the one more NOR gate. Output. The NOR gate is with, we are taking from one input as A, another input as B, okay? And the output of this NOR and NAND gate is given to the, say it is given to XOR gate. XOR gate. This is NAND, NOR, XOR. NAND, NOR, XOR. And we have only, listen, we have only the two inputs. So the number of combinations will be only 2 power 4. Number of combinations. Number of combinations of input equal to 2 power 2 equal to only 4. Okay? So we have the input table as, now we will write a truth table. Truth table. Say the output of NOT gate is the one of the output. We can say this is the X1. Output of the NAND gate, say it is X2. Output of the NOR gate, say it is X3. And the output of the XOR gate is X4. So truth table we can write as A, B. Now how many outputs are we have? These are the inputs. These are inputs. X1, X2, X3 and X4. We have the 4 inputs, outputs, sorry. The number of combination I told you about this one, 2 power 2 is equal to 4. So we have the number of combination here, 4 only. 0, 0, 0, 1, 1, 0, 1, 1. Okay? Now these are the inputs. Now remember, recall NOT gate, A, Q, 0, 1, 1, 0. NAND, A, B, Q, 0, 0, 0, 1, 1, 0, 1, 1, 1, 1, 1, 0, NOR, A, B, Q, 0, 0, 0, 1, 1, 0, 1, 1, only 1, all 0, and the last one is XOR, A, B, and Q, 0 0, 0 1, 1 0, 1 1. Only the same input, the output will be 0 and remaining will be high. Remember this one. Where it is 1. Where it is 1. Where it is 1. And where it is 1. Okay? Now come to the outputs. Here, outputs. Now x1. What is x1? x1 is only the not of A. So if A is 0, the output of the x1 will be 1. 1, here 0, 1, here 1, 0, here 1, 0. x1. Now what is the x2? x2 is the combination of x1 and b. x1 and b. And that is the NAND gate. NAND gate, here the combination, if any one of the input is 0, high will be the output. Any one of the input is 0, output will be the high. So remember only b and x1. 0, here will be 0. Remaining all are high. Understand? For x2. x2 is the output of the NAND gate. And for the function of the NAND gate is that if any one of the input is 0, here the output will be high. Okay? So we are writing here x2 as b and x1. Now remember, come to the point x3 output. x3 is the NOR gate, which is the input of A and B. And what is the function table or truth table of the NOR gate? Here. And the output is only high when both the inputs are 0. Remaining all outputs will be low. If all inputs, if any one of the input is high, the output will be 0. Otherwise, if both inputs are 0, output will be high here. So come to the point, we have to write only the output high when both are 0. So here, A and B. A and B 0, we write 1 here. 0, 1, we have to write 0. Because if any one of the input is high, output will be 0. Here again 0, here again 0. Okay? Now come to the point x4. x4 is the output of the XOR gate. The XOR gate is having the function table as if the difference input 0, 1 or 1, 0, difference input, the output will be high. And what will be the input for the XOR gate? The output of NAND gate and the output of NOR gate, that is x2 and x3, these are the two inputs to the XOR gate. And the combination of these two x2 and x3 will produce the output XOR. That is called x4. So we have to see x2 and x3. Only we can put output is high if x2 and x3 both inputs are different. If both inputs are same, the output will be 0. Here 1, 1, input are same, put 0. 0, 0, again the inputs are same, put 0. Here 1, 0, 1, 0. These are two different inputs. So we can put 1 and 1. So this is the truth table for the combinational circuit. These are the truth table for combinational circuit. We can put truth table for combination circuit. So these are inputs and that are outputs. Output of the gates. This is the output of the gate of NOR. This is the gate of NAND gate, NOR gate and XOR gate. Hope you will understand this topic, combinational logic circuit. I will give you the activity for this combinational circuit. and do it at home and send me the answer. Example, question, write the outputs of the given combinational logic circuit. The combinational circuit is like two input AND gate, say A, B, and we are using the one more gate, NAND gate. The input to the NAND gate is same, A and B. The output is given to the NOR gate. Say output is x1, x2 and x3. Okay? So you have to write the output of x1, x2 and x3. Means you have to write the truth table like this one. Truth table inputs A, B, outputs x1, x2, x3. So you have to fill this one, x1, x2, x3. I am just writing this for 0, 1, only inputs 1, 0 and the last one 1, 1. Complete this one and send to me. Okay? Thank you very much. This is the topic for the combinational circuit, logic circuit. Hope you will be understand. Thank you very much.